Yeah, welcome dear students to this discussion of the JEE Advanced question paper of previous years, and we have a question from JEE Advanced 2023 paper 2. It's a paragraph type question. A paragraph is given, a matter is given, and there are two questions based on this paragraph. A pretty long paragraph. A trinitro compound, it's from organic chemistry. 135 tris 4-nitrophenyl benzene on complete reaction with an excess of tin and HCl gives a major product which on reaction with an excess of sodium nitrate and HCl at 0 degrees Celsius provides P as a product. Now P upon treatment with excess of H2O at room temperature gives a product Q. Bromination of Q in aqueous medium furnishes the product R. The compound P upon treatment with an excess of phenol under basic conditions gives the product S. The molar mass difference between the compounds Q and R is 474 gram per mole, and between compounds P and S is 172.5 gram per mole. It's an additional information just to check whether the structures of Q and R are correct or not. And the question is the number of heteroatoms present in one molecule of R. Heteroatom means atoms other than carbon and hydrogen. So these atoms are known as heteroatoms in the compound. So you have to find out the number of heteroatoms present in one molecule of R. And there is another question which we will see after discussion of this question, which is to find the total number of atoms in the molecule. So let us try to answer this question. So again, not a complicated question, but the compound given is 135 tris 4-nitrophenyl benzene on complete reaction with an excess of tin and HCl. So there is one reaction with tin and HCl, and then you have a reaction with sodium nitrate and HCl, okay, to give the product P. And upon treatment with excess of water at room temperature gives the product Q, and bromination of Q gives the product R, and the product P upon treatment with an excess of phenol under basic medium gives the product S. So let us try to write down the structures of P, Q, R and S. Okay. So the compound is 135 tris 4-nitrophenyl benzene. So this is benzene. Tris at positions 1, 3 and 5. Okay. 4 nitrophenyl groups. Nitrophenyl groups. Okay. At position 1. And position 3. And position 5. So this is a starting compound. Okay. And this starting compound, it is reduced by tin and HCl. Reduction by tin and HCl will convert the nitro groups to amino groups. Okay. So you have the compound amino group amino group. Amino group. Okay? So that is the compound which on treatment with sodium nitrite and HCl, the reaction with the sodium nitrite and HCl, that is nitrous acid, below 5 degrees Celsius. It is the very common reaction, what you call diazotization. So during which the amino group is converted to the diazonium salt. So reaction with NaNO2 HCl at a temperature less than 5 degrees Celsius gives the diazonium salt. And triple bond N plus, Cl minus, okay, and here also you have N triple bond N plus, Cl minus, and here also you have okay, and that is the product P. So simple, the nitro groups are reduced by tinded HCl to amino groups, the aromatic amines, primary amines, as you know, undergo the diazotization reaction and reaction with the sodium nitrate and HCl, so to have the diazonium salt. So all the three NH2 groups undergo diazotization to form this compound P. And upon treatment with water, with excess water, this compound, the diazonium salt, is decomposed by heating with water. What happens is the diazo group is completely detached and the position is occupied by OH group, a reaction which is very familiar to you. Benzene diazonium chloride, on heating with water, you had phenol. A similar reaction takes place here at all the three groups, and therefore the product formed in the reaction is that is the product in the reaction. Okay, this is a product in the reaction, and this product is given the name Q, spin Q. Now bromination of this compound is brominated with the bromine water, excess of bromine water. You are reminded of the reaction of phenol with the bromine water to give tribromophene. The bromination takes place at the ortho position and the para position. Now the para position is already occupied. That means during bromination, the two ortho positions of the OH group will be brominated. That will take place in all the three rings, and therefore the product obtained will be this one. Okay, you have Br, you have an OH group here, here you have an OH group, here you have an OH group. No, here you have an OH group, it's an OH group here, it's an OH group here, there's an OH group here, and you have bromine atom here. Okay, the ortho positions are occupied by the bromine atoms. Okay, so that's the compound obtained when the compound Q is treated with bromine water. Bromine water, this is a compound formed, and that compound is given the name R. Okay, and the compound P, another reaction is given in which the compound P is treated with phenol under basic conditions. This compound P is treated with phenol under basic conditions. A diazonium salt with phenol under basic conditions. It's a coupling reaction, very familiar to you, the azo-di formation. So the phenol will react at the benzene diazonium chloride part at the diazonium group. The phenol will react, the coupling reaction, to give the azo-di. So what is the azo-di that you get? The azo-di obtained will be this one. Okay, here you have okay. Then you have an N double bond N group, and it is there that the phenol couples. This takes place and double bond N, you have phenol, and here also you have, okay, I write here only, okay, N double bond N, you have phenol. So very symmetrical, all these molecules appear to be very symmetrical, very pleasing molecules, very attractive molecules in that sense. So you have the nitrobenzene units at 135 in the starting compound. When it is reduced by tin and HCl, you have the aminobenzene units or aniline units at the 3 positions. Then diazotization gives the diazonium groups. Here, benzene diazonium chloride groups at the same positions 135. And then reaction of this compound with phenol in alkaline medium, that is coupling reaction forming azo-di, and you have the azo-di structures at all the 3 positions. So this is the compound S. And okay, so this is the compound R. On bromination of the compound Q, this is the compound R. So reaction with SnHCl converts the NO2 to NH2, the NH2 to diazonium chloride by reaction with the nitrous acid, NaNO2HCl below 5 degrees Celsius. Then treatment with water, heating with water, warming with water gives the phenol structures. Here the diazonium compound is decomposed to phenol, so you have the compound Q. And on reaction with the bromine, bromination of the ortho positions, at the ortho positions of all the 3 phenol rings to give the compound R, and reaction of the diazonium chloride with the phenol in alkaline medium, azo-di formation at all the 3 positions, and you get the compound S. So this is the chemistry that is given in the paragraph of the question. This is the chemistry given. And this chemistry is not at all difficult. Only thing is that the molecules involved are somewhat big molecules, and if you want to write the complete structures, it takes time, but you need not write the complete structures. You can do things of this sort even in your mind. It's a symmetrical molecule with the nitrobenzene units at 135. That's a starting compound. Then the nitro groups become amino groups. The amino groups become diazonium groups. The diazonium group coupling reaction with the phenol, you have the azo-di groups, okay? And then heating the compound with water will convert the diazonium group to OH, and now bromination will introduce the bromine atoms at the ortho positions of the 3 rings of the compound to get the compound R. So these are the compounds. This is P, this is Q, this is R, and this is S. Okay? And the first question is the number of heteroatoms. Of course, you can verify this Q and R of what the additional information is given, but even without doing that, you can proceed. Why? Because this chemistry is not at all complicated, and if you are able to write this chemistry of the paragraph, then you can boldly answer the question. And what is the question? The number of heteroatoms. That was the question. The number of heteroatoms present in one molecule of R, present in one molecule of R, the number of heteroatoms present in one molecule of R. This is a compound. So what are the atoms present other than carbon and hydrogen? What are the atoms present other than carbon and hydrogen? Other than carbon and hydrogen, you have 2 bromine atoms and 1 oxygen atom in one ring. Okay? You have 2 bromine atoms and 1 oxygen atom in one ring. That means you have 3 heteroatoms in one ring. So 3 heteroatoms here in the second ring and 3 heteroatoms here in the third ring. So in all the 3 rings you have 3 heteroatoms each. So 3 plus 3 plus 3. So the total number of heteroatoms are 9. Very simple. Count the number of heteroatoms. The 2 bromine atoms and 1 oxygen atom in one ring. So 3 such rings in the compound R, and therefore you have 3 into 3. That is 9 heteroatoms in the compound R. 9 heteroatoms in the compound R. Okay? So the answer is 9. It's a paragraph type question. A paragraph is given and you are asked questions which are integer type questions having a particular integer as the answer. The integer here is 9 for this question, the number of heteroatoms in R. So if you are able to write what is R, then there is no difficulty in counting the number of heteroatoms in the compound. And correctly count the number of atoms, don't miss anything, and you get 9 as the result. And coming to the next question, it is the total number of carbon atoms and heteroatoms. Total number of carbon atoms and heteroatoms present in one molecule of S. Total number of carbon atoms and heteroatoms. Total number of carbon atoms and heteroatoms. Carbon atoms and heteroatoms present in one molecule of S. This is one molecule of S. Okay? In one molecule of S, how many carbon atoms are there? Look at the structure of the compound. You have 1, 2, 3, 4, 5, 6, 7. 4 plus 3. 1, 2, 3. Okay? 1, 2, 3, 4. Right? 5, 6 and 7. You have 7 Benson rings in S. 7 Benson rings means 7 into 6. 42 carbon atoms. I hope you understand. Look at the structure of the compound. And how many Benson rings are in the structure? 1, 2, 3, 4, 5, 6, 7. Okay? 1, 2, 3, 4, 5, 6, 7. So 7 Benson rings means 7 into 6. Each Benson ring contains 6 carbon atoms. So 7 into 6 is equal to 42 carbon atoms in the compound. Right? And what about the heteroatoms? Okay, look at the heteroatoms. There are 2 nitrogen atoms and 1 oxygen atoms in this one unit. In this one unit, you have 3 heteroatoms. 2 nitrogen atoms and 1 oxygen atom. In this unit also, you have 1, 2, 3. 2 nitrogen atoms and 1 oxygen atom, 3 atoms. And in this unit also, you have 2 nitrogen atoms and 1 oxygen atom. That means 3 heteroatoms. So 3 heteroatoms in each of the azo structures present in the compound. 2 nitrogen atoms and 1 oxygen atom. So 3 into 3, that is equal to 9. So 42 plus 9. So the total number of carbon atoms and heteroatoms, the total number of carbon atoms and the heteroatoms will be 51. So that will be the correct answer, 51. So what is important in answering such questions is to carefully read the paragraph and try to present the chemistry that is given in the paragraph. If it is organic chemistry question, you will have to write down the structures and very carefully look at the structures and then in this particular question, counting the number of atoms. And while answering such questions, what is important is don't forget to count an atom. It's very important you count all the atoms present in the molecule very carefully, then only you will be able to get the correct answer. So a little bit of extra care is needed in answering such questions. Apart from knowing the chemistry, some extra care is needed in answering such questions. Okay? So that's all. Thank you so much for patient listening. Goodbye.